Hello, ladies and gentlemen. Um, we are moving to another topic for this week. Yes, maybe in the next 1 week or 2 weeks, we'll be dealing with logarithms, with some of the questions we can lay our hands on for this part. So this is logarithms part one. Okay, we have logarithms, the ones that are to base 10 that you have to check. Um, you know, the logarithm of base 10 to this, check under this and that, but this part is the one that involves calculations. Okay, the one that does not involve base 10. So that is what we term as theory of logarithms. So to avoid too much words and too much stories, I've been able to break it down. Okay, if you have log n to base a equals to y. Okay, log n, let's say n represents a number. Okay, a represents a base, y is equals to power to which a is raised. Okay, of course you understand what I mean by power now. Power can be index. Okay, so instead of me to use power, I can also use index. Okay, which is understandable from the indices we've treated, okay, in the past. So now this is the fourth topic, if I'm not mistaken, that we're picking. So before you know it, we'll be done with every topics in mathematics, and you will see how simple those topics are. So now, if you are writing this not to base 10, okay, don't forget a is equals to base. Okay, so instead of me putting 10 here, I'm putting another number, maybe 2, 3, maybe 4, maybe 9. Okay, so if I'm putting another number there and we are representing it like this, that is what we call theory of logarithms. Okay, theory of logarithms. Log of a number to a particular base, which is not base 10 in most cases, equals y, is what we call theory of logarithms. Nobody will ask you the definition of this. Okay, I'm just giving an illustration so that by the time we dive deep into laws of logarithms, like the way we have laws of indices, we also have laws of logarithms, and they are a bit connected. So that is why I had to jump on this topic, so that there will be a kind of flow of understanding. So don't forget, n is number, a is base, y is equals to power to which a is raised. That implies, this is a symbol for that implies 1, which is this equation 1, can be rewritten as number n equals a raised to power y. So that is the meaning of what I mean by saying y is equals to power to which a is raised. This is a and is raised to power y. Okay, it's as simple as that. That is just a simple introduction on theory of logarithms. The next thing we'll be doing is just for us to see how we can solve example under this part, okay, under this introduction. So then in our next class, we will now be treating laws of logarithms one after the other without rushing, so that we can get the understanding of what we are talking about. So the first example that we have here, find the value of the following logarithms. Okay, some people can call it logarithms, some people can call it logarithms. It depends on the one that suits that suits you. So the first one I have here is log 2 to base 32. Okay, find the value of log 2 to base 32 in an option, or perhaps in your classes, maybe SS1, SS2, SS3, and you are asked to find the value of this. So you don't need to stress yourself, just go straight to the point, and then you have just say that let log 2 base 32 equals, you can use any alphabet. Like I told you, in mathematics you can play with any alphabet you want. You can play with from A to Z. It depends on the one. Let me use M here. I'm using M here. So if log 2 base 32 is equals to M, so now the next thing for me to do is that I want to get this value of M. That's what they mean by this question. Find the value of the following log 2 base 32. So I'm assuming that the value of log 2 base 32 is equals to M. How do I get it? All you just need to do is just to make reference to this equation, which is equation 2. Okay, what is my n? My n here is what? 2. Okay, from, just say from equation 2 above, equation 2 above. Okay, I'm just using that illustration so that you can understand what I'm trying to say. So my n equals 2, then my a equals what? 32. Okay, then the third one, which is y is equals to the power to which a is being raised. So it means that this one is what? The third one is 32 raised to power m. Okay, so that is 32 raised to power m. That is the power to which a is raised. What is my a? My a is 32, and that is, so that implies that I can now write 2, okay, which is my n now. Okay, 2 equals, what is my a? 32. What is my y? My y in this case is what? M. Okay, my y. Okay, which means that, okay, let me write it here so that we won't get confused. My y equals what? M. Do you see it now? So it means at the end of the day, I'm having, that implies 2 raised to power, 2 equals to 32 raised to power m. And don't forget, in law of indices, I said before you can cancel base, you have to make it the same. Okay, it means that at the end of the day, this one will be what? 2 equals 2 times 2, 4, 4 times 2, 8, 8 times 2, 32. So it means you 2 in 4 places. 2 times 2, 4, 4 times 2, 8, 8 times 2, 2 times 2, 4, 4 times 2, 8, 8 times 2, 32. That is what, that is, it means it's 2 raised to power 4, all raised to power m. That is the meaning. So don't forget, law of indices. This is what? Multiplication. So this is 2 equals what? 2 raised to power 4 m. Okay, and like I told you, anything raised to power 1 is that thing. So it means 2 can cancel, 2 can cancel. I can now bring the power down, so which means that 1 equals what? 4 m. So what is my m? It means that I can divide both sides by 4. Divide both sides by 4. Okay, let me just write it here. Divide both sides, divide both sides by 4. So when you divide it by 4, at the end of the day, your m, it will now be what? That is 1 divided by 4 equals 4m divided by 4. So 4 will cancel 4. So which implies that your m equals 1 over 4. It's as simple as that. Okay, which implies that your m equals 1 over 4. So all you just need to do is just to conclude. You now say, therefore, your log 2. You now say, therefore, the value of your log 2 to base 32. Because it's an objective, you don't need all the story. But if it's theory, you need to conclude. Okay, so that you can get the understanding. So therefore, log 2 base 32 equals what? 1 over 4. It's as simple as that. Just come and replace the value of your m here. Log 2 base 32 equals 1 over 4. It's as simple as that. So that is straightforward. That is how to get the value. So let's, this one is clear now. For me to do number 2, and example 2. So we are doing example under this part so that you can get the introduction of theory. Okay, so now we're done with that. So we'll move to number 2 here. Number 2 is log 27 base 3. Okay, we'll apply the same method. Okay, let's log 27 base 3 be what? Let me just say k. I'm using, you can use any alphabet. Okay, that implies, so like the way I've explained the first one, I don't want to repeat that because you might not necessarily need that, because the examiner already know what you're trying to do, what the law you're applying, what theory of logarithms is all about. But in that first question, I intentionally illustrate that so that you can get the understanding of what I'm doing. So that implies I can, from equation 2, let me just say from equation 2, from equation 2 above, that implies that I have 27 equals 3 raised to power what? K. It's as simple as that. So in this case, my n is what? 27. My a, which is base a, look at it here. My a is what? 3. So my y in this case is what? K in this case. You understand? So now, like I said, law of indices. If you've not gone through indices, you've not gone through sort, you've not gone through algebraic process, which is factorization using quadratic formula, please go through them so that you can have a full glimpse of what we've done so far. So in this case now, I need to make left and right the same base. So how many times can I multiply 3 to give me 27? 3 times 3, 9. 9 times 3, 27. So it's 3 times. So this is 3 raised to power 3 equals 3 raised to power what? K. It's as simple as that. It's just like chin chin and pure water. So simple. So what do I need to do? I cancel my base. Okay. So when you cancel the base, you bring down the power. So which implies that K equals what? 3. It's as simple as that. So therefore, the value of log 27 base 3 is equals to what? 3. That's the conclusion. It's just so straightforward. Please try and ensure to comment, try to like and share so that we can reach a lot of students preparing, or maybe in SS1, in SS2, in SS3, preparing for GC, preparing for NECO, preparing for WAEC, and then and then some of them you still need some basic understanding of these topics in some of the international exam, which is GRE, IELTS, and so on and so forth. Please ensure we continue to share so that we can, bridge the gap of young mind losing interest in mathematics, just for them to see that mathematics is very, very is interesting. Thank you very much, and then see you to complete the other question in our next session. Thank you.